This is lesson 5.7, Spontaneity. So, Gibbs free energy allows us to predict whether a reaction will be spontaneous or not. Gibbs is equal to the change in enthalpy minus the temperature times the change in entropy. If delta G is less than 0, the reaction will be spontaneous. If delta G is equal to 0, the reaction will be at equilibrium. But if delta G is greater than 0, the reaction will be non-spontaneous. So delta G of formation, or the standard free energy of formation, is the free energy at 1 atmosphere. And this again should look familiar. You can find the standard free energy of formation by using an equivalent of Hess's law. So the sum of the moles times the free energy of formation of the products minus the sum of the moles times the free energy of formation of the reactants. And we use delta G of formation at standard temperature, which is 25 degrees Celsius. But what if we want to find the free energy at other temperatures? This is where we need to use our equation, the change in enthalpy plus the negative temperature times the change in entropy, where delta G equals delta H minus T delta S. So if the reaction is exothermic and becomes more random, both of these are favorable, and so our delta G will be negative and the reaction will be spontaneous. If we have an endothermic reaction and we become less random, both of these are unfavorable and our delta G will be positive, meaning that it will be non-spontaneous at all temperatures. The tricky part is when we have a favorable entropy change, so an exothermic reaction, but our reaction is less random. This will only be spontaneous at low temperatures. It will be non-spontaneous at high temperatures. Depending on the temperature, delta G can be positive or negative. And also, confusing is if we have an endothermic reaction, but we're becoming more random. Unfavorable, favorable. This will only be spontaneous at high temperatures and non-spontaneous at low temperatures. You must know this chart.